Hi, in this video we are going to go over how to create basic particle effects inside Unreal Engine. We are going to be using the new Niagara visual effects authoring system. It is still in beta at the time of this recording. What makes this new system better than the old Cascade system is the full modularity that it provides, and the ease of access when developing new modules and features. I have already went ahead and downloaded the base project. In fact, I have done the basic setup for the landing cinematic. Let me close the editor for that for now. As Niagara is so new, it is not actually enabled by default. So let's enable the plugin. For that, open up the settings in your level editor view and open the plugins option. I have some other plugins present, don't worry about that. We care about the built-in options, and let's search for Niagara. We want to enable the base plugin as well as the extras for it. If I tick this enabled option, I get a warning that the plugin is still in beta, that it can be unstable and there can be issues when upgrading engine versions. Although the API is somewhat mature at this point, be aware of that. So we are going to be clicking yes, and also enabling the extras plugin. For the plugin to be enabled, we need to restart the editor. I'll do that now. Now let's get to creating the new effects. For that, I'm going to be adding a new folder in my content folder. I'm naming it particles. And when I right click in the content browser, we have a new subsection here called FX. There are many options here. First, we want to create a new emitter. When I pick that option, a new emitter wizard pops up with a bunch of presets that are available to us. I'm going to be tackling the dust blowing effect underneath the ship first, and this fountain effect seems to be a decent starting point for that. This created a new emitter asset for us. I'm going to be naming it any_dust. And now let's open up the editor. I'll be docking it next to my level editor view. We can see that the fountain effect itself is already working. On the left here we have the viewport. Over that we have the main toolbar. To the right of the viewport we have the parameters. And to the right of that we see the breakdown of the emitter. We'll be doing most of our work in here. And on the bottom here we can see the timeline. The emitter itself consists of multiple modules, and the modules are grouped into different sections. We have modules that handle the whole emitter settings, when the emitter itself is spawned and how the emitter is updated. We have another section for the particles and modules that handle their particle spawn behavior, and a separate section for their update. And in the very bottom here we have the rendering section, where you can define the way that you are actually rendering the particles. If you want to, you can actually use multiple options. Right now this emitter uses sprites. Or in some cases you don't want to render the particles at all and use them in a different emitter, for example. In an instance where you want to combine multiple emitters, you have to do that in a system. Because actually if we go back into the level editor and try to spawn the emitter itself, we can't do that. So let's create a system based on the emitter that already exists. For that, right click on the emitter and choose the topmost option of Create Niagara System. I am going to be renaming this to ns_dust. Now I can actually drag this system into the level, and I can see the particle spawning. Ctrl+Shift S to save everything. And like I mentioned before, if I open up the system, I can add multiple emitters. Right now we only have the dust emitter, but if you needed to, you can have two versions of that, and you can change the parameters of each one individually if you want to. But that won't affect the base emitter that we have over here. For now, let's close the system. And let's start updating our emitter so that it actually will start looking more like dust. First, let's try to get the motion of the particles to look more like dust plumes. For that, let's take a look at this particle spawn section. Firstly, we initialize the particles and set a bunch of parameters on them. But after this, we add velocity to them. Let's see how this is done. The velocity is set with the random ranged vector uniform. There is some velocity on the x and y axis, but most of the velocity is affecting the z axis of our particles. If I disable this module, we can see that the particles no longer fly out and drop straight down due to the gravity force that is applied to them. I want the particles to fly out in a circular direction around the source. For that, I'm going to be defining the spawn velocity a bit differently with a different module. Let's add that module now by clicking this plus button here. Let's scroll down to the velocity section and let's choose the add velocity in cone option. Right now the velocity itself is set to 0, so let's increase the initial velocity to, for example, 5 meters per second. Right now the particles fly off in the x direction because that is the cone axis direction. Let's switch this to the z axis. The cone angle is set to 45 degrees. Let's use 180 instead. And let's actually increase the initial velocity a bit more. Now we can see that the particles fly out in a circular pattern. Though they fall down due to gravity as previously mentioned. We can disable that module for now and see that they're now flying straight in the horizontal direction. As this resembles the effect I want to achieve a bit more, I'm actually going to be getting rid of both the gravity module as well as the default add velocity module, because we have our new add velocity in cone module here. Right now the addition of the velocity happens in only the XY plane. Let's add a little bit of randomness to this. For that, let's take a look at the cone axis here. To the right of it is this drop down arrow. Although right now the cone angle is a constant, we have a bunch of different ways how we can define it. We can also write in HL, SL expressions if we wanted to. But we care about the random option. So let's search for random. And what we want to use is the uniform range float. This switched our angle from a float value to a uniform float value. That is randomized between the minimum and the maximum values, which right now is 0 degrees and 1 degree. So let's increase the minimum value to, let's say, 160 degrees and the maximum value to 190 degrees. Actually, it seems that the maximum angle is clamped to 180 at this point in time. I like this motion more, although I want my particles to slow down a bit more. For that, let me expand the drag section in the particle updates. And let's increase this to 0.5 or 5 to demonstrate this a bit better. 0.75 seems like a good value here. Now what we want to do is make our particles bigger so that they can be represented by the billboards with some dust textures. For that, let's go into the initialize particles section and let's change the sprite size. As I want the sprites to be scaled uniformly, I'm actually going to be overriding this vector 2 with the float variable. So let's search for float. And let's use this. And actually let's make this a random uniform as well. Uniform range float is the option that we want to use. Let's say the minimum size should be 20 and the maximum size should be 100. Not much seems to have changed. This is due to the calculate size by mass module being enabled. If I disable this, now we can see that the larger particles are around 100 units in diameter and the smallest ones around 20. And because we don't want to use this calculate size by mass option, let's get rid of this module as well. Now, if I increase the size even further, this now starts looking like a dust bloom, but it lacks a little bit of detail. So to add some, let's go down to the rendering section and let's change the material. I know the material I want to use, so I'm going to be searching for cloud. Let's select the cloud lit with shadows option. Let's give a moment for the shaders to compile. Now we can see that our effect is vastly different from the look that it had before. But this doesn't look quite correct. Let's take a closer look at the material itself. In here we can see that our material is actually made up of multiple smaller subframes. These subframes make up an animation in fact. Let's try using that animation in our effect. For that, let's go back into the emitter. We can close the material and let's look in the sub UV section. Right now the whole material is used to generate the sprites, but in this case we want to have 8x8 subsections instead. This is better, but right now all the sprites are using the first image of the flipbook in that texture sheet. What we need to do is for each particle update the subframe of the flipbook during their lifetime. For that, let's go into the particle update section and let's add a new module. And let's search for animation. Let's add the sub UV animation module. Right now only 4 frames are used, so let's switch this to 64. This added a little bit more life to our particles. To make the blending a bit smoother, let's enable the sub-UV blending option. And now let's save our effect. Going back to the base map, we can see that we now have a nice dust plume. Now looking at the effect a little bit closer, we can see a little bit of banding near the terrain. This is due to the way that this material is set up. So let's open up our cloud material again. And let's add a fade node in line with opacity. The depth fade node to be more precise. So let's rewire that in. The default fade distance of 100 units should be fine. So let's save it now. And now taking a look at our particles, we can see that those harsh lines are now gone. Let's save everything and let's close both our material as well as the emitter. And let's go on with adding in the next effect. For that, navigate back to the particles folder and let's add a new emitter. The next effect that we want to create is hail raining down. For that, the hanging particulates template is a good start. So let's create a new emitter. Let's name the new emitter NE_hail. And let's open it up. Right now we can see that the particles just float there in the air. So in this case we actually want to add the gravity module ourselves. Let's go down into the particle section, particle updates section, and let's add the gravity module here. Looking at the module, we can see that there is an error associated with it. This is because the gravity force was added after the solve forces and velocities module in the stack. To fix that, we can click this fix issues button, or we can just grab the module here and move it on top of the solve forces and velocity option. Actually, in this case, let's move it on top of drag, because in that case, the drag is applied after the gravity force, which should look a little bit better. The particles are falling down, but they are so small that they are hard to see. So let's increase their size. Now we get a bit better of a view of the particles. This hail effects only covers a very small area, so let's increase the spawn area. For that, let's look into the particle spawn section and let's open the box location here. Right now, the spawn area is 400 times 400 times 100 units. So let's increase the X and Y dimensions of it. 40 times 40 meters seems a bit better. There is also this sphere location here that adds another little bit of randomness. You can take it or leave it. In my case, I'm going to be getting rid of this. Now this looks better, but in my case, I want to make it look like an actual hailstorm. So for that, let's increase the spawn rate of the particles. So in the emitter section, let's expand the spawn rate module. Right now the spawn rate is 50, meaning 50 particles are spawned per second. Let's actually increase this to a very large value. Let's say we want to spawn 5,000 particles per second. Because this system is so optimized, having these 30,000 particles at a time is very much still possible. But if you want to make our particles a lot lighter on the system, let's actually switch the way that they are simulated. Let's open up the emitter properties again, and let's change the sim target from CPU simulation to GPU simulation. There is one small issue with the effect right now. That is, if I look away from the center of it, we can see that the effect itself disappears. This is because the bounds of the effect are so small. If I enable the visualization of the bounds in this main toolbar here, I can see that if I change my viewport enough so that the bounds no longer are visible in the viewport, the effect itself disappears. To fix that, let's try setting the fixed bounds. Now we can see that the blue box that makes up the bounds is a lot larger, and the effect is actually visible even when I'm not looking at the origin. If the bounds was made too small for you, you can also manually adjust it here. Now let's save our emitter and let's add a system based on this emitter into our scene. For that, let's again right click on our hail emitter and create a Niagara system based on this. I'm going to be naming this NS_hail. And now let's drag a version of that into our scene. And let's move it upwards a little bit. Having deselected the system, we can now see that the particles do work, but there is one issue. All of the hail is actually going through the ground here, but we can fix that as well. Let's go back down to the particle update section and let's add a collision module. The default collision option is fine. Again, this was added after solved forces, so let's click this fix issue here. Now it was moved above it. Because the default simulation target is CPU sim, the particles are actually no longer spawned. So let's switch this to GPU compute sim. The collision type of depth buffer is fine. So now taking another look at our level. Oh, actually I need to apply and save this. We can now see that our hail particles actually bounce off the ground. Right now this doesn't quite look like hail. So let's add a little bit more motion to our particles. Again, in the update section, let's add a wind force. And let's move this on top of both the solver as well as the collision module. And let's define our wind speed. Let's say that the wind is blowing 10 meters a second in the x-axis. Let's also scroll up a little bit and let's increase the curl noise amount, because right now it isn't really visible. Let's increase the noise strength to a higher value, let's say 1000. And let's decrease the frequency by 5. And let's also decrease the drag to 0.2. Now, having saved the emitter, let's take another look. This is somewhat better, but right now the particles are bouncing a little bit too much. So let's go back into the collision section and let's drop the restitution down to 0.1. Let's save again and take another look. Now the hail is bouncing a lot less than it did before. And as the last thing, let's decrease the particle size. For that, let's go into initialize particles section and let's say that our hail pellets range from 1 centimeter in diameter to 5. This works well enough for me. Let's save everything and let's go on to adding our last effect. That is going to be the engine thrust effect for our spaceship. Same deal, let's add a new emitter. And let's actually use the very same fountain preset. I'll be naming my emitter NE_engine. Let's open it up. And now let's start modifying the effect again. Because I want the effect to be localized near the engine itself, I'm going to decrease the particle lifetime to a very low value, from 0.05 to 0.1 seconds. I'm going to be deleting the calculate size by mass option, and I'm actually going to be getting rid of both the gravity force as well as the drag force. Now I'm going to be increasing the particle size, but this time I don't want the size increase to be uniform. So I am going to be increasing the size in the Y direction to 150. This isn't quite the effect that I want, because the particles are not facing in the same direction. For that, let's go down into the render section and let's change the alignment to velocity aligned. I'm not a huge fan of this white color, so let's change that as well. The scale color option makes the particles fade out as they get older. We could do the same with the RGB section. But instead, let's define their spawn color. So let's add another module in the particle spawn section. The simplest color option will work. Let's choose a better option here. I'm going to go with a little bit of a teal color, and I'm going to make it glow by increasing the value. To see how the effect will look in the end, I'll be placing a version of this into the level. So let's save it. Go back to the level editor and add a system for it. I'm going to be naming it NS engine and dragging an instance into the world. Right now, this engine effect is a little bit too small. So let's make it appear a little bit more proper. Right now they are spawned inside a sphere. I can increase the radius. But as the engine was more of a rectangle, let's actually use the box option instead. So let's get rid of the sphere here. And add the box location. Let's decrease the Z size to 0 to make it a flat rectangle. And also let's decrease the size in the y-axis to 30. This is somewhat better, but we have too few particles, so let's increase the spawn rate to a very high value of 1000. And instead of them flying upwards, let's make them fly downwards. For that, I'll be changing the z values from minus 18 meters a second down to minus 36 meters a second. Also, let's increase the size of the sprites in the x-axis a little bit as well. This is a little bit blobby, so I'm going to be increasing the value in the y direction as well. Now going back to the level editor, we can see that this now looks like a much more powerful engine. But there is one more small issue that we should fix. That is that the particles actually lag behind too much. To fix that, let's go back into the emitter properties, and make the simulation happen in local space by ticking this flag here. Now let's save again. And now when I move this effect, I don't see any of the lagging anymore. So now let's parent this effect to the engine itself. The effect is beneath the front right engine, so let's parent it here. Let's take another look at our cinematic. This is looking somewhat better, but we have one issue. The dust effect is spawning even if the ship is not on top of that. So let's try animating some of the parameters of this effect inside our sequence. Let's add it to our sequence. Let's add a track for the actual Niagara component. Let's say that we want the dust sprites to start spawning around this time here. Right now we are lacking the parameters to do that, but we can fix it quite easily. Let's go back to the content browser. Let's open up the Niagara system for the dust. Here we can see the system exposed parameters. Let's add a new parameter. It's going to be a float, and let's change its name to user.spawnRate. The namespace is important, so do leave the user string here. Now we need to link the newly created parameter to the actual spawn rate of the emitter. For that, let's open up the spawn rate option here, and let's search the user created variables and add our spawn rate here. This didn't seem to work, but that is because I added the duplicate version of the dust emitter here. So let's get rid of that duplicate. Now we can see that as the default value of our parameter is 0, no particles are spawned. And as I increase this value, we can see that more particles start spawning as I increase it. Let's leave the default to be 0. And let's save our system. Going back to the level editor, we can now see that no particles are spawned. Now let's go into the sequencer, and inside the Niagara component, let's add in the track for our newly created spawn rate parameter. Let's key the innermost spawn rate track. Let's set the value to be 0 here and 50 around here. Let's actually get rid of the outermost version of the parameter. And let's add in another key when the ship should be more or less landed around here. Now, if we play back the animation from this point, for example, we can see that no particles are spawned, and we start getting the dust effect as the ship lands. For now, let's take one last look at our sequence. You should add the engine effects to other engines as well, and give them a similar treatment. That's it from me. Thank you.